Here are your solutions to 4-7. These are the letter problems. So we'll start with letter A. It asks us to determine whether each table represents a linear or a nonlinear function, and then to explain it. So we can look at this really quickly by checking each cell. Remember, you must do each cell, and from 0 to 5 is a plus 5, from 5 to 10 is plus 5, and from 10 to 15 is plus 5. So the x values change by 5 in each case. We move to here and we go from 20 to 16. We are subtracting 4. 16 to 12 is subtract 4, and 12 to 8 is subtracting 4. So our change in y would be right here, -4, over our change in x would be 5. We have a constant rate of change. We have a slope, m equals -4/5. So we have an answer for letter A, that it is linear, first of all. And secondly, they asked us to explain. And you would say that as x changes by plus 5, so I would say change in x is plus 5, and the change in y is -4. They are both constant. That is your explanation. We have a constant change in both x and y. Now let's take a look at letter B. From 0 to 2 is plus 2. 2 to 4 is plus 2. 4 to 6 is plus 2. So we have a plus 2 in this case. In the x values, the inputs. For the y values, the outputs, we have plus 2 from 0 to 2. But from 2 to 8, we have a plus 6. And from 8 to 18, we have a plus 10. So this is nonlinear. And your explanation would say that the change in x equals plus 2, but y, or we should say change in y changes in each cell. It is not constant, would be another way to put it. The change in y is not constant. That'd be a great way to get right to it quickly. Not constant. Change in y is not constant. All right, let's take a look at letter C. C tells us that tickets to the school dance cost $5 per student. Are the ticket sales a linear function of the number of tickets sold? Explain. So again, we can look at all three cells here. We're plus 1 from 1 to 2, from 2 to 3 also plus 1. So we have a constant change in x. Change in x is a plus 1. Now let's look at our change in y. From 5 to 10 is a plus 5, and from 10 to 15 is a plus 5. So we have a constant change in y. So they ask us to explain. First of all, we would say yes, it is linear. And secondly, we would say that the change in x is plus 1, and the change in y is plus 5. Those changes are constant. So we have a linear function. Another way to look at this is, if you think about this, it says tickets to the school dance cost $5 per student. So we could say our output, how much they're going to cost, equals 5 times the input. And immediately you can look at that and say, well, this is the equation of this line. So we clearly have a line here because this is in the y equals mx plus b format. We don't have a plus b because we have no y-intercept, but this is indeed the equation of a line. And some of you will recognize that just by seeing that this is a constant rate of change, $5 per student, automatically you can put that into a linear equation, which of course means that it is a line. Letter D. A square has a side length of s inches. So again, we're looking at a square here, and we're saying that the side is s. The perimeter of the square is a function of the side length. Does this situation represent a linear or a nonlinear function? And then, of course, explain that. Well, we could make a table of values if that's what we wanted to do here. We could put our input, of course, is side length. Our output is area. We could put in an input of 0. Well, 0 times 0 would give us an area of 0. We could put an input of 5. Well, 5 times 5 would give us 25. And then we could try an input of 10. 10 times 10 is 100. Over here we have plus 5 in all situations, so our change in x is plus 5. And over here our change in the y values, or our area, here it's plus 25, but here it's plus 75. So first of all, we would say immediately that our answer is it is nonlinear, and then our explanation would be that our change in x equals plus 5, whereas our change in y is not constant. Would be a great way to put this. Not constant. Our change in y is not constant, and that is why it is nonlinear. This is the one we graphed earlier, where if you think about it, it would keep rising quicker and quicker and quicker, because this equation is a equals s squared, which is clearly not a linear function because we have an exponent here. We'll learn more about that later. Please do guided practice.